So why don't you set the scene and then we'll get cracking.
So the Fermi Paradox, is there life out there, and what's the potential that we would find it?
The Fermi Paradox started with a question by Enrico Fermi, that the premise is that the galaxy is well old enough for life to have arisen older than us. It had billions of years to do so. If that's the case, it really doesn't take all that long in geologic timescales to travel around the galaxy, travel around the Milky Way. You can do it in millions of years, essentially. So why hasn't anyone? And that is the paradox, that when we look, we see no evidence of alien civilizations in the Milky Way. And we certainly have no evidence that they would be here. So that's the premise. Why is it that there's no one else here? Now, solutions to the Fermi Paradox are numerous. As of right now, I know 75, roughly.
Just 75?
Just 75. So these range through a bunch of scenarios, which we'll get into. And I guess we could take a few of the more prominent ones and
I mean, a few more just like sort of set the scene, because I think like the people watching right now, and I mentioned this before, are already thinking of reasons why. And I guarantee that every single one of the reasons that you think of are on that list of 75. And I guarantee that I've got that there is a very good answer to almost or all of them. So, I mean, it gets weirder than what you said, right? Like, the universe is, like, here on Earth is 4.5 billion years old. The moment the Earth cooled down to the point that life was able to thrive on Earth, it did. So we can see this continuous record of life on Earth. The second life could have gotten going on Earth, it did. And our Earth at 4.5 billion years old is only a fraction of the age of the entire universe. That slice of time, the universe has been hospitable to life almost right to the very beginning. Definitely 10 plus billion years. We've missed the most active star forming time of the universe's history. We're in the party's over, and it already was really exciting much earlier. And so again, it's like there are 2 trillion galaxies in the universe. There's 100 to 400 billion stars in the Milky Way alone. There could have and should have been so many opportunities for life to exist everywhere. And the challenge is that we don't see any life. Everything that we've tried to do to be able to look out into the universe, we're not able to see it. And you may say, oh, the universe is too big, people can't travel. But remember the implications, right? The numbers are so big, right? If even 1% of our Milky Way forms intelligent civilizations, that is 100 stars. 100 stars people should have been traveling out from these 100 stars. Across the universe with 2 trillion, you're looking at tens of thousands, millions of potential civilizations moving from star to star. And if they couldn't, then we won't. And that is the sort of the implication, is that every reason that you think of to say, well, maybe it's just too far, and maybe they don't want to, and maybe they go into a virtual world, and maybe they travel to another dimension, and maybe then the numbers are still so big that any one of them should have not done that, and we should see their evidence somewhere. And yet, from what we can tell, none of them have done it.
How about this one? All civilizations invariably destroy themselves before they develop interstellar space travel.
That's what I was going to say.
Right.
A good counter to that, but
Yes.
I'm not supposed to have any bias, so I'm going to say,
Oh, you're moderating.
Yeah, I'm moderating. I have no bias.
So that's the scary one, right? That's the one. That's the great filter. That's this idea that there is some event that has stopped every single civilization from being able to make this journey. And again, when you think about the implications, if it has stopped 1 million advanced civilizations in our observable universe from doing this, what are the chances that we can stop it? Like, maybe they have. What are some ideas? For the great filter that you find really compelling?
Well, I think my particular view on this is that the Fermi Paradox only applies to civilizations, alien civilizations. I don't apply it to alien life. because I have a sneaking suspicion that our universe is a largely microbial one, and that
Right.
it teems with microbial life. But there's a problem, and it's early in the Earth's history, life arose, as you said. And in fact, there's some papers out there that are pushing that date back further and further,
Yeah.
even into the late heavy bombardment.
Yeah.
That would seem to say that the chemistry that gets life going is pretty straightforward.
Yeah.
And that we'll eventually figure it out in the labs, and we'll know. And we can say this is hard or it's easy.
Yeah.
And if it's easy, then the life is probably everywhere. But there, life sat, doing nothing. For, I believe,
3 billion?
yes,
Yeah.
it was not. Life was very simple for billions of years. Then we get the jump from prokaryotic to eukaryotic life, and that starts it out. Oh,
Microphone is recording everything
oh God,
you're doing. Don't tap.
yeah.
All right.
Hey, we can cut that out.
Okay, yeah.
Because I have an editor.
Yeah, you have an
so,
editor.
Yes.
Yeah.
You, on the other hand,
I'll
get
rely
tabs.
on your editor, and then I'll rip the audio from your editor instead. Yeah.
So, to me, that leap seems conspicuous. You know?
And in fact, you can trace all of the multicellular life here on Earth back to one common ancestor.
That's right.
That only happened once.
Only once, and we haven't seen it repeat.
Right.
So that to me seems like a pretty good, great filter. That life tends to get stuck in a microbial state.
And for a good portion of time.
Yeah, or maybe permanently.
Maybe
You know,
never.
yeah.
Because you do require one organism to basically absorb another, and
And not kill it.
Yeah, not
Yeah.
digest it. So it's
Not destroy it.
It's
Yeah.
a little bit interesting, but since it did happen, it shows that it's possible. So it may happen every 10,000 times, maybe the leap happens,
Right.
or the leap will happen somewhere in the far future. It just hasn't yet, and then eventually you'd have this explosion of intelligence in the universe, as time goes on. That's my suspicion. Is that's the big filter, but I actually don't mind that because it still creates a universe where it's teeming with life, and intelligence occasionally occurs.
Yeah.
May not interact with each other.
Yeah.
And there you have it. That it's just simply a lot more complicated to have what we have than what was previously thought.
Yeah, I mean, I would tend to agree with you that the like the fact that life got going as quickly as it did, that literally the moment the conditions on Earth were safe enough for life to exist, life got going. And there's this idea of panspermia, that maybe life came from Mars, or maybe life came from another solar system out there. And that's interesting, and there's compelling evidence that this is possible, but it only pushes the question back. So it just says, well, then how did life get going on Mars? Well, how did life get going on Venus? How did life get going on Alpha Centauri before the asteroids carried the microbes through the vast intercosmos reaches to be able to arrive here?
Right.
And so still, I mean, I hope you're right. I hope you're right that the great filter is the jump from single cellular to multicellular, because the other option, and we should talk about that, is that it's in our future. That the thing that stopped all civilizations from exploring the cosmos was something else happened to them.
There's that's the other thing, is that we have an obvious problem with this world. We affect it profoundly, and we pump its atmosphere with CFCs,
Yep.
and then we see the effect, and then we stop in time. But what if we hadn't stopped and we just fought about it, and it became a political hot potato issue?
That sounds familiar.
Oh, weird.
Mhm.
Yeah.
I'm alluding to, of course, anthropogenic climate change, which everybody's gonna go after me on that one, I'm sure.
Come at.
Yeah, come at
Yeah,
us.
send the emails to me.
Yeah, send them to Fraser.
Yeah.
Since we do that, other alien civilizations, in order to do what we do, probably go through that stage where they use maybe fossil fuels or whatever. I would assume it would be fossil fuels. And they would then also go through the same climate change. And if that's an extinction level threat, then it's simply something that happens over and over and over, and that you just can't get to a technology that's clean enough to save your own planet.
Right,
You'll always
and
hit
there may not be enough energy deposit. Like the fact that we can burn dinosaurs and drive around
Right.
is wonderful, and it has been the thing that has moved our civilization to the stage that it's at. Nothing is as energy dense as dead dinosaurs or phytoplankton or whatever. But and so there's this idea, right? If we wreck it and then the octopuses take over, they're not going to be able to have dinosaurs to burn because we burn them all up. So they're not going to be able to go to space. They're going to have to wait we're going to have to wait several 100 million years for the next generation of forests and phytoplankton to create a new layer of coal and oil for whatever the slug monsters to try and be able to colonize space.
And, that in itself is kind of an interesting thing, because if life is rare in the universe, geologically speaking, crude oil is one of the rarest substances you could possibly ever have.
Yeah.
It's the rarest of all hydrocarbons
Yeah.
because it's produced by life.
But I find that argument pretty weak, because there's two reasons. One is we can predict it. So in other words, the fact that we're having this conversation today, and if we really wanted to, we could stop the climate change. We could stop pumping out the carbon into the atmosphere. We could do a Manhattan project level effort to try and get that under control, and we could avoid it to some degree. And even if we don't get it done quickly, it's not going to wipe out all of the civilization. It's going to hammer human civilization hard, but it's not going to wipe out all life on Earth. It's not going to wipe out intelligent civilization. The kinds of great filter events are more sort of existential in nature, the ones that you can't predict, the ones that come out of nowhere 100% of the time and wipe out any civilization that reaches that level. I imagine, whatever, doing some kind of exotic physics experiment, or berserkers from another civilization.
Well,
right?
that's another valid solution to the Fermi Paradox, is that
It's one of the 74, right?
Yeah.
Yes, this has a number somewhere.
Yeah.
Somewhere.
The idea is that, when you look at other galaxies and you start searching for civilizations, you don't really have a lot of chances to see them unless they've done something amazing, like started arranging stars or doing.
But that's in our future.
That's in our future.
Yeah.
So no one appears to have done
Right.
it.
No one's done it, and that's
Right.
like the best evidence you would possibly see, and yet
Right.
nobody's done it.
So to set that aside and say we just can't detect for sure life in other galaxies, it's just not easy to do. We're looking only in the Milky Way. If there is one civilization in the Milky Way, say it's a machine civilization, they've uploaded themselves billions of years ago, and they decide that all biology that is interstellar capable is a threat, and it just simply destroys them, it hides and then destroys them when they get to that stage. Could be,
Yeah.
and that this is just the first civilization out there that's very quiet, very low key, and it's like a viper. It hits you as soon as you start to leave your solar system.
Yeah, and it is an absolute race, and the first group, as you said, some machine civilization that puts probes across the Milky Way and just waits for anyone to demonstrate any ability to fly to space, and then they blow up their star.
And you could do this simply by stationing a von Neumann type probe in the star system where you have a planet like Earth.
Yeah.
And as soon as they get to a certain level of technology, EMP them back into the Stone Age.
Yeah. Or blow up the star, or
Yep.
cause a super flare off the star.
Exactly.
Wow.
And you cannot ever really, it's a needle in a haystack. Finding a probe the size of a building in the solar system is not
Yeah.
going to be that's something that we may never be able to do unless you were like
Yeah.
radaring local
Yeah.
areas, because the solar system
Yeah.
is so large.
And so when I think about those other options for the great filter, you think about asteroid strikes, you think about worldwide pathogens, those seem like they're not existential. They're not going to wipe out our civilization. And yet, when you think about the things that could, like say AI, some kind of artificial intelligence, we don't see evidence of the artificial intelligence. Like the thing the artificial intelligence would do is dominate the entire galaxy, and yet we don't see any evidence of them. And so it's like, we know that won't happen, or that hasn't happened, because we don't see them converting the Earth and the planets into computronium, which
Right.
you would expect to see if a machine civilization is really they're really putting their back into it.
Do you think that we'd be assuming that would be their intention? However, I mean, what do you think?
Well, there's
I definitely want to hear your response to
okay.
that.
They could also be Borg-like and assimilate,
Right.
And that everybody ends up in the galactic computer when they get to a certain stage, and it's best not to talk to species that haven't reached a certain arbitrary level that they want, and they just keep quiet, and that they live in virtual reality in a galactic paradise, and it's a Star Trek world in there where everybody's interacting.
That's the Mass Effect. You play the Mass Effect
Oh, yeah.
games.
Oh,
That's the gist of that. With I don't want to spoiler alert, but the Reapers.
Everybody in here,
Yeah, fine.
yeah.
The Reapers show up, and they take all of the wonderful new genetic and intelligent diversity that's flowered in the universe after its last reaping, and then they absorb it all, and then they wait another 10,000 years, and they come back, and they come back for round two. And that's absolutely a compelling and terrifying thought. But whenever you come up with a maybe they, right? And I think whenever you say maybe they do, maybe they don't, maybe they can, you have to then say they must all. Like, that's the key, is that the numbers are so big. You're looking at 10,000, a million civilizations out there potentially. And so one might go, we want to just go and live in a virtual reality world. One might say, oh, we wrecked our planet because we produced too much carbon dioxide.
Right.
And we were really stupid, and we're really going to regret doing that as the temperatures spike around the world. But you need to come up with something that works 100% of the time, that is inevitable, that is unavoidable, that's unpredictable. What are those? And again, if you come up with one, then it can't be it.
Oh,
Well,
wait for it.
true. Well,
Because then someone would have thought it, and someone would have tried to prevent it, right?
well, no, I can think of one maybe that might get
Sure.
past that, because we don't know the answer to it. Colonizing Mars is whenever you go to a planet that was once similar to yours, which is the natural one to choose to colonize, something about that planet causes the extinction of your species. And here's how this may be able to happen. I'm skeptical on this one. I got to preface this first. This is not my theory. This comes from a paper.
Okay.
Don't be mean to John, please.
Yeah. blame the
Yes,
research.
don't shoot the messenger. But I do like it because it's frightening.
Yeah. That's my favorite kind of
Yes.
existential threat.
So you have a planet like Mars that was once Earth-like, had liquid water, and could have spawned life. Say it did. On Earth, life wasn't the only thing that arose. So did viruses. And viruses are very complicated things that can only very selectively infect. They're very super complicated. But the idea is that as a planet like Mars dies, the viruses evolve to attack any cell that they can. In which case you have a generalized virus that can slate wipe a planet of all life.
Right. When the virus realizes that we're in the end times, and the only thing we can do is take everything.
Right. And
That
if
is terrifying.
If it generalizes, which means that you can go to Mars, your astronauts go there, and there's a virus there that can already infect macrofauna of any type, so long as it's carbon-based life. And it will, once you bring it back to your home world, it won't just kill you, it will kill everything.
The
Right.
idea that
Including the
Mars
bacteria.
could potentially destroy us.
Right.
Yes.
Right. And so the thought is that there are these.
Elon, if you're watching,
Yeah. Careful
read that
there.
paper.
Watch
But
out.
right. So the idea that there are these planet bombs out there, which died, and they died as they got to a point that the viruses kicked into overdrive. Then the only problem maybe is that viruses
That's
are
pretty apt. Sorry,
are
that's it.
fairly short-lived here on Earth. They're very fragile.
They are.
While bacteria can
And
last forever.
that's one of the reasons why I don't really think this one's too viable, is
Yeah.
because viruses, they really are very, very specific things, and they're just not, I mean,
Yeah.
So, a question I have with this, and I'm curious to hear both of your points on it, is what if we don't know what we're looking for? We think we have these ideas
Right.
and these concepts of what, intelligent life would be and what to look for. Obviously, biosignatures would be huge.
Sure. Yeah.
But thinking of things like ourselves, or, we had a wonderful person suggest, what if it is just a cloud, a very ominous, but all-knowing, being that we don't know really quite how to detect such life in such a...
Sure, if you transcend it
tier.
into a nanotechnological
Right.
cloud,
Yeah.
you would look like a fog bank.
Right.
Right. So, I think the argument against that, the base argument is just the fact that the universe, at its basics, right, is energy that is coming off of stars, that is the only energy that we know of.
Right.
And then there is the raw material, the raw matter building blocks, the hydrogen, the helium, the carbon, and the same chemistry that we're made of. We look out into space and we see that exact same chemistry across the universe. So at the end of the day, all life forms in the entire universe will be essentially competing over the energy from the stars and geothermal and whatever, but essentially energy from stars and the raw material, the matter to build
Right. things
with, the protons and the neutrons. And the assumption that you have to work with is that is going to be that is the resources that we will be battling over. And so when we look out into space, we expect, when we sort of imagine what our future looks like as a civilization, we're going to continue to use more energy. We're eventually going to want to start harvesting energy directly from our star in the form of solar panels. Eventually, we'll just enclose our entire star in Dyson sphere because that's the best way to gather up the energy. We'll dismantle worlds for their building materials. We or our AI overlords will optimize the resources in the solar system to the best of their ability. And then they will move on to Alpha Centauri, and then they'll move on to Proxima Centauri, and then they'll move on to every single star. And then they will arrange the stars in the way that is the most optimal way to gather the most amount of energy and make the most amount of raw materials available to them. And the thing is that is something that we should be able to see.
Right.
We could see a galaxy that some futuristic civilization has rearranged the stars into a shape like a ball or
they've
right.
They've also there's also the idea of the red spirals where they've kicked out all the dangerous stars in their galaxy and as a result it reddens.
Yeah, and that a Dyson sphere, if you enclose a Dyson sphere in solar panels, it would be giving off a very different radiation profile than a regular star. It would be giving off this glow in the infrared as they were dumping the heat, the waste heat out into space, and there's no way to hide that, right? Right. The way, if you try to hide that waste heat, you just turn your Dyson sphere into an oven, and eventually the laws of thermodynamics take over. And so we can see it's a very obvious heat signature that we would see. Astronomers have done surveys and they haven't been able to find them. And so some really futuristic civilization that had moved all the stars into some perfect sphere or this red spiral and kicked out all these other stars, we should see evidence. We should see all the galaxies as we look out into space. They should all be these weird optimized galaxies where the civilizations have been optimized. And we should see the wave where those computer those AI civilizations are coming our way.
Right.
And we see what they've already optimized and what they haven't optimized. And we don't see that. We see wilderness. We see raw wilderness in all directions.
And do you guys both believe, or your takes on, do we have the technology to actually
Detect.
to take on this endeavor?
Surveys have already been done to look for,
We know of the ones, right, but even to go further outside of our own neighborhood, our own galaxy.
Do we have the technology to detect them, or do we have the technology to do this?
To do this, to be able to see some of the ideas that you guys have proposed, like moving
look at the
stars
other galaxies.
to look further into those,
yes.
because we're talking distance.
Yes, we do, but in certain cases. For example, if a civilization was a Kardashev Type 3 super civilization, and they had taken their entire galaxy and encased everything in Dyson spheres, we would see that as an invisible galaxy in every frequency except infrared.
Yeah.
And that would look pretty odd, and all sky surveys in infrared have been done,
Yep.
and they've been done for a long time. So No, we can do it when they do things like that. Now, if they're much more subtle, it's a lot harder to detect.
And what about the problem of time?
Well, that's the other thing is you're really kind of you're sort of limited to your local group of galaxies, because the further out you go, you're looking back into a time that there probably wasn't even enough time for life to have developed. Yeah. And become intelligent.
Yeah.
So that's, I mean, that radius would be, I guess.
But I mean, Andromeda's 2.5 million. You know, we're only seeing it 2.5 million years ago.
You would see Andromeda. Yeah.
Yeah, and so when you think about when life first formed, we'd be looking out, or 4 billion years. You know, that we're looking like a third of the way through the light of the universe.
And so, would you pose that any life would be valuable to?
That's another one.
That is one that I'm curious to hear your point on and your point on. What would be worth looking at if you were one of these higher? Would it be worth looking at humans? Are we?
Well, I mean,
or
so
even us microbial.
Yeah, so it depends on whether they're curious or they're you know. So if you look at it from the berserker standpoint, they're looking for potential threats.
Right.
And so they would be analyzing the state of the various stars, and because you don't want to, like, you want the sun has only so much energy, and the planets have only so many raw resources, so you don't want to wreck that. You want to try and keep them as pristine an environment as possible until you get your hands on it and actually start to get to work with it, which is why you send the berserker probes to wait and observe, and if anyone starts to create a starfaring civilization, you wipe them out and keep that place pristine. So it would be worth it from that perspective to keep an eye on what's going on. And then but let's say they're curious like we are, then just to understand scientifically what's happened in the universe, that would be interesting to them. So I think that there's tons of value for any civilization to look outward.
Yeah, honest question though, do you think we're curious?
Are we curious?
Mm-hmm.
Yes.
I know we are.
Yeah. The human race is, I think, by default, humanity is very curious.
By default, I would agree.
Yeah.
And I don't think you would disagree with that, would you?
I agree.
Right. Do you think that sometimes the ego can take over such curiosity?
To want to look for things that are like us?
Or just, you know, if we were ever having these berserker probes, that how we would actually approach them. What I'm thinking is if we have these advanced civilizations that are far above where we're at, and we're detecting these, we're looking for these, or they're looking for us, I want to know what would make us worth a pit stop.
Well, if life in the universe, intelligent life in the universe is rare, then it may be seen by another civilization, us, as being a very precious thing. And that planets that spawn civilizations are very, very rare, and that's something that they want to keep, as you said, pristine. And that we're just simply in a period where they're letting us develop, and eventually they'll contact us and essentially uplift our civilization. And
that would be nice.
It would be very nice.
Yeah,
but
that would be perfect. Wouldn't that be great?
But you're talking to me, so I have to throw in wrenches.
Yeah.
It could also be that they just simply keep us at this level, or they say they need to be downshifted, and they need to be made stupider.
Yeah.
So they come in and they show up one day and they genetically modify everybody to be no longer capable of being a spacefaring civilization, and we go back in evolution.
Right.
And all of a sudden we're Australopithecines again.
Right.
And then they just let the cycle happen over and over, and they visit every so often.
But I guess the point is, like, that's again thinking about this sort of monolithic point of view about that, right? That you're saying, well, they, but it's not a they. There was 10,000 civilizations. Each one has their own opinion, and one of them wants to downshift, one of them wants to uplift us, one of them wants to turn us into paper clips.
And it becomes a vote.
Soylent Green.
Right?
The civilizations of the Milky Way took a vote on the humans.
Yeah.
And the humans lost.
Yeah, the humans lost. Like we can't agree at that level. Why would aliens across the universe agree at that level, right?
Right.
So I think that, and so again, whenever you get these arguments, whenever someone says they must want to do this, that's like saying here on Earth, right? Humans must want to do this. Like, humans want to do all kinds of weird, different things, and there's no monolithic answer for what humans want to do.
Right.
You know.
And then this is scary because that leads it to where the humans were destroyed when an intergalactic war between aliens broke out over what to do about the humans.
Yeah. Yeah. Yeah.
So what do you think
I would
about?
actually find that satisfying, by the way.
That'd be a good way to go.
Yeah.
Yeah.
I'd be okay with that.
Yeah.
But I mean, do you think that we hold ourselves back as far as going between planets, other places in our solar system,
Oh,
the
sure.
Alpha Centauri system?
Oh, sure.
Well, sure. I mean, yeah. I mean, we build military weapons. We spend whatever $500 million to $1 trillion a year on ways to kill each other. Imagine
Right.
if we spent that money. But I mean, humans have been humaning since humanity began, and that's just
Right.
what we do, right? But at the same time, there are rockets that land at Kennedy Space Center. There are spacecraft orbiting the planet. There are telescopes orbiting Mars. There's rovers on the surface of Mars. Like things are happening. Things will keep going. It may take us longer than we expect, and yet it might jump forward.
There's something really satisfying in this because if we would have rolled back the clock to 2001, I would have said I will never see anyone land on Mars in my lifetime because no one is doing anything. NASA was stagnant.
Right.
Yeah.
And while robotic exploration of the solar system was occurring and doing very nicely, that's one thing that NASA does very well. They don't really do so well on getting everybody together and launching a rocket. And even now, the SLS is that we should have had that rocket in 1985.
Yeah.
It's not really a relevant rocket today.
Yeah.
I mean, I'm sure we'll launch a few of them, but for what it costs, it's
But I'll bet you if you look on the
But now
exponential
it's
curve,
changed.
well, it has changed. But if you look at an exponential curve, a lot of technology is locked into place,
Yeah.
especially computers. So I think a lot of those things were almost inevitable.
Right.
It wasn't Elon Musk. It was going to be Jeff Bezos. Jeff Bezos was excited about space exploration as Elon Musk was.
There was a paradigm shift because now the technology was there to where you could build a rocket that could land. But the thing is that you have sort of like with anything government, you've got a phenomenon where a rocket company, the contractor like Lockheed Martin, or there's no real reason to make a rocket that can land itself when the way it's set up, there's just no incentive for them to do that. They get paid by the government.
But innovation approaches the laws of nature, right? So if you're going to attempt to if you're going to make a rocket that doesn't, even though the rocket equation permits it, then someone is eventually going to figure it out, right? And so you're seeing that with computers, like whenever someone is willing to follow the laws of nature to their inevitable conclusion, then those are the technologies that are possible. You can't make a perpetual motion machine, but you can make a rocket that lands on its launch pad. So and these are all bumps in the road along the technological progress. You can look at the scale of energy usage on planet Earth by humanity, and it is this smooth exponential curve going up and up and up. And even though it was human power, animal power, fire power, steam engines, oil, gas, renewable, all of these, it's just this smooth transition because that's us approaching what nature can provide at the heart of it, right? So then where do we stand, right? I mean, I think that we've talked a bit about the Fermi Paradox, and my hope is that...
Well, I was actually going to ask real quick both of your opinions on the Drake equation, because I know that was mentioned in the Twitch chat, which I can't read from this distance, but...
I think the Drake equation was an interesting idea when he formulated it, but I think it is forever an exercise in banging your head against a brick wall because you can't plug in enough numbers to ever find anything meaningful out.
Yep.
You agree?
I 100% agree. Yeah. It provides no value to answering this question.
Right.
It helps you identify what you think are variables that could be plugged into it, and those are all exciting things to look at.
Mm-hmm.
But it doesn't tell us any way, shape, or form how many aliens there are in the universe. Back to this idea, because they could and should move, and we should see evidence of them everywhere, and we don't.
And so with the potential of an infinite universe, how would you handle something like that?
Right. So we had this conversation. John and I were talking about how we were going to have this conversation, and he's like, "I got a killer argument for you," and he did, and I caved. So
Wait. we're gonna have to back that up. So
Yeah.
go on. Infinite universe.
Okay.
What's the possibility?
Well, we do not know how big the universe is. All we know is what we can observe. So we see the observable universe. This is as far as we can see.
13.8 billion years. That's all we got.
That's all we got. But that does not mean the universe doesn't continue on outside of that bubble. And there's a possibility, a fairly strong possibility, that it's actually infinite. In an infinite universe, not only would you have the possibility of alien civilizations, you have the possibility of running into another Earth, where there's a Fraser Cain and a JMG and a Skylias sitting here having the same conversation. The only difference is that I was having a Manhattan.
And
Right.
yeah, and Fraser has hair.
Yeah.
Yes,
Well,
and
so,
I don't.
and sort of the way to kind of logically go with this argument, right, is that, imagine a cubic meter of space, just space itself. When you think about the number of various, essentially, states that can be in that cubic meter of space, there's like 10 to the power of 80. All of the particles that are possible in that cubic meter, that all the different configurations, all the different energy states, there is actually a finite number of possible states in a cubic meter of space.
Right.
And so if you go in any direction for an infinite amount of time, you will eventually run into a copy of a cubic meter of space, because 10 to the power of 80, even though it is an enormous number,
Right.
it is a finite number, and finite is smaller. An infinite number of finite numbers go into an infinite number. And so you will run into a copy of just some cube of space, like right down to the particle level. And then you'll run into another one, and then you run into another one, and you will run into copies of every single possible configuration that is possible an infinite number of times. And so eventually you'll get to a place that, you'll find a cubic meter that's kind of like, this table, and then you'll find a cubic meter that's, or a cubic kilometer that's kind of like, Palm Springs, and then you'll get a 10,000 cubic kilometers, it's kind of like the Earth. And eventually you will have perfect copies of the Milky Way out there in space, an infinite number of them. And then I absolutely 100% cede the ground to you, there will be an infinite amount of life in the universe.
And therefore, I am going to end this on an even more terrifying sci-fi possibility regarding this.
Wonderful.
And this is the worst one. This is the worst I've thought of. So in an infinite universe that's dying as it's moving towards that, and eventually it becomes just a cinder universe, black, place of blackness, infinite blackness. Then you run into something called a Boltzmann brain, where if you wait long enough, a gigantic supercomputer will appear out of nowhere, out of random noise, and be conscious.
Right. So this idea that there are, this cup sits here on this table, probably. It's a probability distribution that all of the particles are here, but there's also a probability that all of these particles could be in Alpha Centauri. The chance is incredibly low, but if you wait an infinite amount of time, then it will absolutely happen that the particles that are currently here will reform. They will not happen to be here. They'll happen to be in a very unlikely place. And this is absolutely proven by quantum mechanics. This kind of thing happens all the time at the particle level, and it just doesn't happen at the cup level and at the planet level and at the supercomputer level. But if you wait an infinite amount of time,
You wait long enough,
you will get right.
So a conscious thinking gigantic supercomputer appears in the distant universe and looks at the blackness, and it says, I need something to do. So it says, I am going to make a simulation of the universe. And inside of it, I'm going to put one planet full of a bunch of people and experience what they experience while they try to figure out if there's anyone else out there.
Nice. You monster.
Yeah, I was so say I'd watch that movie. Wait, I might live that movie. That's a wrap.
Yeah, right on.
It's amazing.
All right, thanks, guys.
And yeah, we have the live stream still going. We could bring them forward.
Yeah,
if
do
you guys
you all have some questions?